pursuit of continuous quality education.
Living up to DepEd's mandate of no student should be left behind.
From the home of Sarong Banggi,
The land of Oragons. This is Santo Domingo National High School. School on Air.
School on Air.
Good morning to all our listeners and most especially to our grade 10 students who are tuned in right now. This is your radio teacher in science, Teacher Anita. And we are now on our last quarter for this school year. For quarter 4, we will focus on matter and its interactions, which is chemistry. I hope that you are ready for our discussion today. Try to find the most comfortable place where you can get the strongest reception for our broadcast. And please be ready with your paper and pen as you go along with today's episode. Get also your learning activity sheet in Science 10, Quarter 4, Week 1. A minute will be given to you to prepare for our lesson. Are you now ready? For today's lesson, you are expected to investigate the relationship between volume and pressure at a constant temperature of a gas, and investigate the relationship between volume and temperature at a constant pressure of a gas. Lesson for today is focused on Boyle's law and Charles' law. Before we start with our lesson, let us recall first the different properties of gases. This activity is entitled Getting to Know Our Gases. Answer the following statements with a yes or a no. Number 1. Gas has no definite shape and no definite volume. Again, gas has no definite shape and no definite volume. If your answer is yes, then you are correct. Gas has no definite shape and volume. Gas particles can separate from each other and move about randomly in space. Thus, its shape and volume always depend on the container that it occupies. Number 2. Gas particles collide with each other and with the walls of the container. I'll repeat statement number 2. Gas particles collide with each other and with the walls of the container. Yes or no? Yes. The answer for number 2 is yes. Gas particles are constantly moving around freely. During this molecular motion, they constantly collide with each other and the walls or surface of the container. The sum of all these forces causes the pressure exerted by the gas. Number 3. The temperature of the gas depends on how fast its particles are moving. Again, for number 3, the temperature of the gas depends on how fast its particles are moving. What's your answer? Yes, the gas temperature depends on the average kinetic energy or movement of the particles. Hence, gas molecules move faster in higher temperature than in cooler temperatures. The last item for this activity, gases are incompressible. Again, for number 4, gases are incompressible. Is it a yes or a no? The answer for number 4 is no. Gases are easy to compress because the molecules are spread out and there are lots of empty spaces between them. I guess you are now ready for our discussion. From the activity, we have been reminded of some properties of gases. We must be familiar with these properties because we will be using them in our topic for today. Let's recall them one by one. First is volume. Volume is the amount of space occupied by the gases, and they are usually expressed in liters or milliliters. Second is the pressure, or the average effect of force exerted by the colliding gas molecules. The standard unit of pressure is Pascal. It can also be measured in atmosphere, Thor, and millimeter or mercury or mmHg. And lastly, the temperature, which is defined as the degree of hotness or coldness. The temperature of a gas is proportional to the average kinetic energy of its molecules. It can be measured in Celsius, Kelvin, or Fahrenheit. Have you observed the air in a form of bubbles exhaled by the fishes in the aquarium? How can you describe the change in its size as it goes up? Very good. You are a keen observer. As the air or bubbles goes up, the size of the air becomes bigger and bigger. Why do you think so? This phenomenon can be explained by Boyle's law. What is Boyle's law? This law is named after Robert Boyle, a physicist and chemist who discovered the behavior of a gas at a constant temperature. In 1662, he discovered that the volume of a gas decreased as the pressure exerted on it is increased. In other words, at a constant temperature, the pressure of a gas is inversely proportional to its volume. By the way, when we say inversely proportional, if one of the quantities increases, the other quantity will decrease. And if one of the quantity decrease, the other one will increase. So according to Boyle's law, if pressure is increased, the volume will decrease, while a decrease in pressure increases the volume. Let's go back to the rising bubbles in an aquarium that is getting bigger and bigger. What is responsible for the increase in the volume or size of the bubbles? Any guess? Correct. It is the pressure on the gas. The water pressure in the tank increases with depth, meaning the deeper the water, the higher is the pressure. Air exhaled by the fish in a form of bubbles get bigger because of the decrease in pressure as it goes up. As explained in Boyle's law, air or bubbles exhaled by the fish on the deeper part of the tank is smaller because the pressure is high. And as it goes up, there is a decrease in pressure that allows the bubbles to become bigger or increase in its volume. Let's take, for example, the activity given in your learning activity sheet. the Boyle's law experiment using the marshmallow inside the syringe. Were you able to perform the activity? If not, look for the experiment video I have sent in our group chat. Let's try to answer some of the guide questions. What happened to the marshmallow inside the sealed syringe when you push down the plunger? How about when the plunger is pulled up? What happened to the marshmallow? When the plunger is pushed downward, the pressure inside the sealed syringe is increased. The greater force is exerted in pushing the syringe increases the pressure of gas inside, and the size of the marshmallow becomes smaller. When the plunger is pulled upward, the pressure becomes lower inside, and the marshmallow increases its size. Take note that in this activity, the size of the marshmallow represents only the volume of the gas since we cannot see it. The effect of the gas in the marshmallow is the observable one. This activity shows clearly the relationship between pressure and volume of a gas. The increase in pressure of gas causes the volume to decrease, while the decrease in pressure increases the volume. In other words, pressure and volume of the gas are inversely proportional to each other. Let us now proceed to Charles' law. It is the law proposed by a French physicist, Jacques Charles. Charles' law states that the volume of a gas is directly proportional to the temperature at constant pressure. Take note that pressure is constant in this law, and the relationship between temperature and volume is directly proportional. When we say directly proportional, as one quantity increases, the other quantity will also increase. And if one of the quantity will decrease, the other one will also decrease. To show the relationship between temperature and volume, let us take, for example, two setups of inflated balloons of the same size. In setup A, a balloon is placed in an iced water, while in setup B, the balloon is placed in a warm water. What do you think will happen to the balloon in setup A? How about in setup B? According to Charles' law, the volume of a gas is directly proportional to temperature. In setup A, the balloon is exposed to an environment with a lower temperature. Therefore, the decrease in the temperature will result in a decrease in the volume of the gas inside the balloon, causing it to reduce in size. While in setup B, the balloon is exposed to a higher temperature. That will make the gas inside the balloon heat up. The increase in the temperature of the gas inside the balloon would result to an increase in volume or makes the balloon bigger. Let us discuss some of the real-life applications of Boyle's law and Charles' law. One of the most common applications of Boyle's law is the action of the syringe. A syringe is a medical device that is normally used to withdraw or inject fluid from a patient's body. You may have experienced being drawn with blood using a syringe. How would you describe the volume inside the syringe when the plunger is pulled up? Correct. The volume increases. And what will happen to the pressure inside the syringe if the volume is increased? According to Boyle's law, an increase in volume will lead to a decrease in pressure. This will result in a difference in pressure outside and inside the syringe. And since the pressure outside is higher than the pressure inside, blood will be drawn inside the syringe. Are you familiar with the Clark's hot air balloon in Pampanga? Or maybe you may have seen them in the news. It is an annual event that features beautiful and colorful hot air balloons. Do you know how a hot air balloon works? The working principle of a hot air balloon is simple. By heating the air inside the balloon with a burner, the temperature of the gas inside increases. The hot air expands as per Charles' law. As the temperature of the air increases, the volume of the air also increases, and consequently, the density decreases. This makes the hot air balloon lighter than the atmospheric air surrounding it. The buoyant force pushes the lighter balloon up in the air and it flies. We are almost done with our lesson for today. Let us summarize the topic we have discussed. We have learned in this episode about two of the fundamental gas laws, Boyle's law and Charles' law. Boyle's law states that the pressure of a gas is inversely proportional to its volume at constant temperature, while Charles' law tells us that at constant pressure, the volume of a gas is directly proportional to temperature. At this moment, let us check your understanding of the concepts tackled. Write true if the statement is correct, and write false if it is not. Write your name and on the answer sheet, and don't forget to submit them on Thursday. Number 1. Robert Boyle is the proponent of the gas law that describes the direct relationship between volume and temperature at constant pressure. Again, for number 1, Robert Boyle is the proponent of the gas law that describes the direct relationship between volume and temperature at constant pressure. Number 2. Pushing down the plunger of the syringe increases its pressure and the volume decreases. I repeat for number 2, pushing down the plunger of the syringe increases its pressure and the volume decreases. For number 3, pressure is proportional to the average kinetic energy of its molecules. Again, for number 3, pressure is proportional to the average kinetic energy of its molecules. Number 4. When the temperature of a gas is doubled in a confined container at constant pressure, its volume will increase 2 times. I repeat for number 4, when the temperature of a gas is doubled in a confined container at a constant pressure, its volume will increase 2 times. Last item. A hot air balloon works by burning up the fuel to heat the temperature of the gas to increase its volume and decrease density. Again, for number 5, a hot air balloon works by burning up the fuel to heat the temperature of the gas to increase its volume and decrease density. And for your enrichment activity, try to explain how these laws are applied in the following real-life examples. In your grade 9, you have taken up the respiratory system. Explain how Boyle's law can be applied in the lungs and diaphragm in breathing. Again, explain how Boyle's law can be applied to the lungs and diaphragm in breathing. For number 2, Have you seen the warnings written on the deodorant bottles? They suggest storing it below 50 degrees Celsius and also warn to keep it away from direct sunlight and ignition. How can you explain this using Charles' law? Again, for number 2, explain using Charles' law why deodorant bottles are advised to be stored below 50 degrees Celsius and to keep them away from direct sunlight or ignition. Good job, everyone! I know you will be able to get the correct answers. Don't forget to hand in your answer sheets together with your outputs on Thursday. And we are now done with today's episode of Learning. I hope that you have learned something from our discussion. If you have questions, don't hesitate to ask me or message me in our group chat or messenger. As Albert Einstein once said, the important thing is not to stop questioning. Once again, this is your radio teacher, Teacher Anita. Goodbye and have a nice day, everyone.